Really quickly. All right, guys, let's talk about these. So first things first. I want us, again, move into the center so that you're not on those edges. Make sure that we can clearly see this. So, I need y'all to hear me very clearly on this. The number one issue that students run into with all of these equations is, one, they don't practice, and two, they don't learn their equations. When I say standard form, what should immediately jump to your mind about that equation?
Ax squared plus b plus c.
Standard form, think alphabetical. Standard form, think alphabetical. Ax squared plus bx plus c. You got to know that equation, backwards and forwards. When you don't know these things, it's going to get a little hard for you. And it's easy right now because we just did the Desmos activity. If you take the time to log into that Desmos activity, you can actually always go back to it because it has a log of every Desmos activity you've ever done. So I would make sure at some point I log in and you can use that to study and help you see those things again. But that's my standard form. I've got to know that equation. And I've got to know what is determining my concavity. Y'all got all these right. What's determining concavity? A?
Yes.
Is that right?
Yes, sir.
That leading coefficient, what's out in front? And so please hear me clearly on this. When I talk about this first equation, is it minus 3x plus 6? Is that what it says?
Yeah.
Yes. So what is my A?
2x squared.
Just 2.
Remember, hold on. X squared is x squared, right?
Yes.
So A is just 2.
Right.
The x squared tells me where my A is, right? But the A is just at number 2. Please notice how I said A equals 2. So the concavity is what? The most common thing that I see students do that is very incorrect is they'll say 2 equals concave up. Or they'll tell me, hey, A is equal to concave up. But what is A? A is not concavity. A is a number. A is not a concavity. It tells me my concavity. What is A? A is 2.
Yeah.
Because A is 2, the parabola is concave up. Okay? Now, standard form, what's the other feature that we should be able to quickly see? Don't have to do any extra work. What should we be able to quickly see?
The y-intercept.
The y-intercept.
The y-intercept is C, right?
So the y-intercept is C?
Yes, sir.
And did I show y'all why it should make sense that it is C?
No.
Well, I don't think you showed everybody.
Okay, so let's look at this. What do you know about every y-intercept that has and will ever exist?
It's by itself.
The y-axis.
I was saying, remember, it's on the y-axis. Building off of the idea that it's on the y-axis, what is that x value, Kalia? 0, right? Isn't that 0, 1 right there?
Yeah.
That's 0, 3 right there. If you have a point on the y-axis, the x value is 0. So what can x be if I want the y-intercept?
0.
So this is an explanation of why. Notice, what's anything times 0?
0.
So does it matter what a is?
No.
Not at all. What's b times 0?
0.
And so if I have an input of 0, I get 0 plus c, which is c. My y-intercept is always 0, c. You can go into Desmos and you can see that happening regularly, but also it makes sense when we understand what a y-intercept is.
Gotcha.
Every y-intercept that has and will ever exist, the input is 0. Now be careful with this as well. A y-intercept is a what? Ready to make better decisions.
Point.
You weren't trying to throw something a second ago?
No, I literally did 0.
Oh, okay. My bad. Alright. What is that x value?
A point.
The y.
Sorry. What is the y-intercept? It is a point. Make sure you write y-intercepts as points. The c is 6 for this one, but the y-intercept is 0, 6. Okay? For as far as I can tell, we got all these right. Now, the one thing I do want to point out is what I saw J Mike doing is great on the back end. You grab the calculator, right, and you graphed it, and you're like, oh, it's concave up, and the y-intercept is 6, right?
Yeah.
Yes.
You can literally see that. The point of this activity, though, is to be able to look at an equation and roughly know what the graph looks like without a what? Without a calculator. Now, can you use a calculator to help you check?
Of course.
Yes.
100%. Now on assessments, no. But if you're doing the practice, if you're doing the learning, should you take the time to check yourself?
Yeah.
100%. Practice checking yourself. But we want to be able to look at the equation and roughly know what the graph is going to look like. And so on an assessment, literally, if you identify these things, 1, 2, 3, 4, 5, 6. Y-intercept is 6, and the parabola was concave up. So I'm not going to put my vertex here, but I would accept this graph, or I would accept this graph. Because are those concave up?
Yeah.
Does it have a y-intercept of 6?
Yeah.
Only one of those is correct, but does that have the features that you can easily see from that equation? So either of those would be acceptable. That's what I'm going to be looking for. I'm going to be looking for you to identify your features and then do a quick sketch off of those features. That's it. So if I were you, I would grab a quick seat and I would get out my, remember I passed out the standard, factored, and vertex form for error models yesterday? Kennedy, you need that, right? Okay. You should have those. I would add some notes to those. And remember, there are check your understanding questions. You don't do those check your understanding, it will bite you eventually. Do the practice, do the check your understanding. Yes, you go. So remember, which form did we just
Standard
form? Yes. So guys, remember, which form did we just examine? Standard form. Don't just write down the answers, write out whatever explanations you need. Maybe grab one of the equations on the board and show how this plays out. Justify your answers. All right. Just Ken, hold on one second. I'm looking for Kennedy's, or resources for Kennedy. May have to print them back out. Alright. Oh, I did not throw them away. We are going to study 3 forms of the quadratic. The standard form. We're going to study the standard form, the factor form is next, and the vertex form. And so you'll notice practice problems for each of those words. You have 2 standard views. You can do this with one, just be aware that that vertex for that form there has the practice that you
What they do is, so I get from the company, the testing help.
standard, factor,
I have the process where I get in, they put it in a bottle.
yes, standard form, right? Is that what we call this one?
And you just take 15 milliliters a day, put it in your water, and you drink it every day.
Well, I mean, you could write down what one of these, or maybe that one we just did, and show an explanation. So remember,
It ain't that type of detox.
we talked about
It
that
ain't that type, I wouldn't even be here. I wouldn't even drink it. I wouldn't be embarrassed.
Did you explain why you circled A? Right, so remember, we need to say, hey, A is determined concave. When A is positive, that parabola is concave what? When A is negative, that parabola is concave. See, like, these are notes explaining why it's important that you can use later to help you study.
What's the standard form of quadratic?
Which form have we been exploring this whole time, Picard? Wait.
It's just the justification.
So, Miss Kenny, got that down like this?
Hey, you haven't answered. All the justification is tell me why you think that's the answer. Show me words, show me what's going through your brain. That's it. Right? Put your words down, huh?
The vocabulary, there's the point, but.
Yes. Remember, that's just function notation. That's a good question. Alright. Yes.
Okay.
It look like that.
Why is that down?
Okay. Let's look at it. So, ladies and gentlemen,
She's talking about your hair.
before we start on the next part of this, right? Addison was already looking at the first section, the mild section. What does it say? H of x equals what?
Negative 4x squared minus 3x plus 1.
Okay. Now, one thing I want to address is a question Kamaya was asking. Now, remember, Kamaya, try to identify those things before we type it into the calculator. But Kamaya was looking at it, she was trying to type it into the calculator, and she was like, wait, it says h of x here, but in the calculator it says stuff like f1 of x and f2 of x. You will see times when I use j of x and m of x. It doesn't matter what this is here. What is this indicating?
Yeah. Well, sometimes.
Equation started.
It starts the equation. It's also the what for the relation or the function. That's output.
Oh, yeah.
It doesn't matter what letter it is. That's just an output, right?
Yeah.
And so like this is function 2. This is the function j. This is the function m. It's to indicate the difference between different functions. So the letter here doesn't actually matter. What matters is what expression it is equal to. Okay? So it can be any notation, and that's why I have those different functions on check your understanding like that. Now, Addison, you were asking why is this concave down? Why did you think it was concave up?
I don't know. I just thought, I don't know. I never said it. I thought it was concave.
Okay, you just didn't know why it was concave down? Okay. Let me ask you all this. Remember, what form do we have here? We have standard form, right?
Yeah.
So, remember how with linear functions, right? As soon as you realize it was linear, I told you to write what? As soon as you realize it was linear, what did you need to write? Slope-intercept form, y equals mx plus b, right?
Yeah, yeah.
As soon as you realize something is exponential, what do you need to write? A times b to the x, right? That's to help you. As soon as you realize this is standard form, what could and should you write out?
AX squared
Plus bx.
plus BX plus C.
Two things I want you to remember about this. Every time you write that, what's it going to help you do? Remember it, right? Every time you write it, it's going to help you remember it. Two, it's going to help you identify different pieces. Does anyone remember which of those values helped me determine concavity?
A number, I mean negative.
I was saying, remember, it was only the A. Because that A is negative, this parabola is concave down like a frown, right? Remember how frowns are a negative thing. A is negative, so that parabola is concave down. Okay? Addison, does that make sense now?
Yes, sir.
Notice, when you do check your understandings, I can more easily address the confusion and the questions that you have. So I need you to check your understandings at home, in other classes. Actually, don't do that in other classes because you're supposed to be learning, but you and I both know some other classes you have downtime, take advantage to not be on our phones, maybe do that, but do it at home, doing it during advisory when we're not throwing pencils at our group mates, right, Amber? Thank you. Smooth, Tosh. All right. So what questions do you have about this standard form before we move to the next form? I mean, this is
I know
a,
how to do like
so like, I mean, you know the shape of a parabola, right?
yeah, but like, just
But like, you don't have to make it, so, okay, I got you. So, two things with a parabola, okay? You will never see a parabola that looks like this. Okay? Anyone know why that would not be a parabola? Say that one more time. Two things. One, aren't parabolas symmetrical? Okay? So we need to be careful with graphing it. That's where more details the better. The other issue I have is this. You know what this relation isn't? Look at it.
They one side more on out.
Yeah, but look at this. What is this relation not?
Oh, it's not a function.
Why is it not a function?
Because it's going straight down, it ain't going at an angle.
Right, like if it's going straight up and down, right, and I don't know if this is seen in the camera, but if you draw a relation that looks like this, This piece right here would make it not a function. That's one input with lots and lots and lots of outputs, right? Be careful when drawing a parabola to make it kind of slope out on both sides. Notice that is not perfect, but that would be enough detail as long as you have the right concavity and the right y-intercept. Does that answer? Let me make sure that answers Jamie's question. Yes? Come on.
I don't know how to work it, so you gotta come in. So you can work it yourself, but I don't know how to work it. Now I'm just confused. Okay, so if I did this right, I did it left and I go down, what I do after this?
Okay. So y equals x squared. Was it plus 2x?
Yeah.
Minus 3? So, can I realize that this y-intercept is negative 3? And then what else do we know about this parabola? It's concave up. You got two different options. It's concave up, so it could look like this. Or, it can look like this. Notice they're both parabolas, they're both concave up, and they both have that y-intercept. We will learn about how to find what the vertex is soon, but as long as you have one of those two things, that's all I care about. It has the right y-intercept and it has the right concavity.
Yeah, I didn't know when I was supposed to point.
Hey, did you check the answers on the backside? Remember, these are check your understanding. It doesn't help you to practice without them being able to check it. Alright, so check against it. I will note again, I did not make that y-intercept the vertex because it is not the vertex. So we are now moving on to slide 7. Whoa! Okay. Now, once again, we are moving on to a new form. We are done with standard form. We are moving on to, notice, this says, what up here? Factored form. Now, I want to emphasize and point this out. Mathematicians, we're not original. When we say factor, what should you think about? Multiplying, right? What's happening between a and these parentheses? What's happening between this binomial and this binomial? So why is it called a factored form? Because everything is being multiplied. Use the language to help you, because if we understand that language of factors, we're talking about multiplying things. And so everything is being multiplied at some level, right? So factored form is that a times x minus r1 times x minus r2. Make sure you pay attention to the directions at the top of the slide, because on slide 7, what is the only value that you are manipulating? You're only manipulating a, seeing how a affects the parabola. Once you finish coming up with a conjecture on slide 7, you're going to move to slide 8. And you're going to write that conjecture and your answer to slide 8 on the board. And if you're done with slide 8, you're going to move to slide 9. Okay? Keep it going, rocking and rolling, right? So, if you are still taking notes, finish your notes while the rest of your group starts their, by the way, pause. Hey guys, what form are we looking at right now? Factored. So we should be writing this on standard. Okay? Don't write this factored form stuff on standard. Only put standard on standard so that there's no confusion, okay? Keeping those details straight is important. That vocabulary is important. So if you are done with notes, go ahead and get up with your group, work on slides 7 and 8. I will come by. If you have questions about anything prior to this, ask those questions during this time. Now do you see a red light flashing? Alright, J-Mike.
Yo.
Let's look at this. So, first things first, I just want to emphasize this. I talked about it with a couple of groups. Okay. Breaking in, lights warning. So, what did A do? We have this factored form up here. It's got an A. What did A control? Control the concavity. So right now, A is positive and that parabola is concave up. When A becomes negative, concave down. Okay, so why do you think we use A in this factored form just like we did in standard form?
Because A is a very important feature.
Not just because it's an important feature.
Because it's a number here and being multiplied by.
Yeah, kind of. Do they mean similar things or different things?
Similar.
Why do we use A? Because remember with standard form, hold on to that, but in standard form, we used ax squared plus bx plus c, right?
Yeah.
I don't have a b or a c here, but I still have an a. Why do I still have an a?
Because A
Leading
is,
coefficient.
It is leading coefficient, but also because it does the same thing.
yeah.
The reason why we use a again is because that is, and I do like that language, it is the leading coefficient. We're going to learn how to go from this factored form to a standard form, and that a is still going to be a. And so what I want you to hold on to is, if we're using the same letter, that's because it is the same thing. If it's a different letter, it's doing something different. But a controls the what?
The concavity.
The concavity of that parabola, right? If a is positive, that parabola is concave up like a cup. Guys, remember, parabolas cannot be positive. I would point out, right here, this parabola on this side has negative x values, but up here it has positive y values, negative y values, but positive x values. So we can't say a parabola is positive or negative. That parabola is concave up or concave down, okay? So be careful about that, but A controls the concavity. That's what we should have said for slide 8. And then we move to slide 9. Notice the language. When I say explicitly connecting, whenever I say something like that, that means that value is on the graph, right? We couldn't see A on the graph, we could just see what it was doing. But when I say it explicitly connects to the graph, that means there is a point that is my roots. What is the point that connected to the roots? What do we see there? The x. I need more than just x. But x-axis isn't a point. Say it again. X-intercepts. We need to be careful with our language on this, and I don't know. Oh, there it is. I want y'all to see this. Right? Right now, R1 is equal to -3, correct? R2 is equal to 1. And so, do I see -3 and 1 on the x-axis?
No, well, yeah, but you can't physically see no.
I mean,
Oh, I ain't seen them.
yeah. All right. So now, one thing I want to caution you, right? X-intercepts and x-axis are different things. This is my x-axis. Can you change that x-axis?
No.
No. You can change points on the x-axis that we call x-intercepts, right? You cannot change the x-axis, but you can change the points on the x-axis called x-intercepts, okay? So, I want to remind you, earlier on standard form, we had a y-intercept, and that y-intercept was what? How did we always identify the y-intercept? 0, comma, c, right? The input was 0, the output was c. So how do you think I'm going to talk about the x-intercepts here?
R, comma, whatever.
Say that one more time.
R, comma, 0.
R, comma, 0, super close. The only reason I say super close is that is as dead as a marker gets. How did that happen? Nope, we were closer earlier. So I want you to notice with an x-intercept, what is always true for every x-intercept that's ever existed? The y is,
The Y is 0.
right? It's on the x-axis, so my y is 0, okay? The only reason I say kind of when you said R earlier is, how many x-intercepts do we have? 2. And so that's why we have an R1 and an R2. Now I want y'all to be careful about this, okay? Two things to be careful about with this. Actually, the first one's not to be careful. The reason why we use R here, why our book uses R, is because that's known as a root. The root is that value from the equation. There's a little detail about roots versus zeros. We're not going to sweat it. But we call this a what? Root. Okay? Most things in math, there's a clear reason why we call it that. Why we call it a root, I don't fully know. The only thing I could get close to when I literally spent hours trying to research this is if you think about this almost like ground and plants, this would be like where the plant grows above. This is where the root starts for a plant. Literally, that's the only thing I could find that made it make sense. Okay?
Yeah.
But that kind of makes sense why we call it a root. It's where the root starts. okay? And then we expanded from there. Now, here's where I need you to be careful. What is the equation, I'm going to change that A just a little bit. What is the equation that we have currently? What is the equation that I have based on my A, R1, and R2?
2 times x minus 3.
So 2 times,
X minus.
wait, hold on one second, you said x minus 3, right?
I mean, minus negative 3.
So remember, it's minus a negative 3, and then x minus 1. Now I need y'all to be careful about this, because this is where most students get tripped up on factored form. When I subtract a negative, what does it actually become? Positive. Okay, so I want you to notice, when it's x plus 3, is that a positive or negative root? A negative root. When it says x plus 3, that is actually a negative root. When it says x minus 1, that is actually a positive root. And that is one of the biggest things that trips students up. But there's a couple of details to note here and pay attention to. Right here, you see where it says x minus R1?
Yeah.
So notice how it has a minus, so it's always going to be the opposite of whatever the sign actually is. Sorry, these purple markers are crappy. I want to.
Pick on another one.
I got like a whole box here. They're just like really get better. All right. So we want to notice that it is going to be the opposite. And I'm going to show you two things that I have realized recently that I hope help it make sense. Like they're things I knew, but I hope they help it make sense because it's just something I didn't talk about in the past. Yo, someone turn this down hard.
It's hot.
It's hot?
Yeah, no, it's cold.
Pretty high.
I was like, listen, I like the cold and I saw it was comfortable, so I assumed y'all were not. But we'll figure it out. Tyler's already trying to fall asleep on me, so I know it's too cold. So, okay, really quickly. Hey guys, I need y'all to look at this. Oh, that's a good marker. Because I want y'all to understand this. Okay, hey, right here. So f of x equals 2 times x plus 3 times x minus 1. If I want x-intercepts, what do I know about my output? If I want x-intercepts, what do I know about my output? The output's what? 0. Now, Duan, do you remember what we're going to call this right here? What property we're going to use?
Zero product.
Ah, nice. I want y'all to notice this factor form. Ow, that hurt to hear. We're multiplying, right?
Yeah.
Yeah.
If I were to tell you that a times b is equal to 0, what do you know about a and or b? One of them's got to be what?
0.
0. The only way to multiply two things and get a 0 is if one of them is 0. So, what we can do from here is I am multiplying and I have a product of 0. So I'm going to use the 0 product property. Hopefully you talked about this in Algebra 1. If you did not, hold on to this and go ahead and start using this language because it is a critical part of your next unit. So either 0 is equal to 2, or 0 is equal to x plus 3, or 0 is equal to x minus 1. Now which of these equations cannot be?
You said what happened?
Which of these equations cannot be?
Which all quit?
Remember, it's I got a product, right? So each factor is set equal to 0.
X equals 2.
Can 0 equal 2? No. So do I actually need that piece?
No.
But right here, I need y'all to pay attention to this. What would I do to solve this equation to find x?
Both sides.
I would do what both sides?
Subtract.
Notice if I do 3 minus 3, what do I get?
0.
What is 0 minus 3?
-3.
Do you see how that is the opposite of what's right here?
Yeah.
So that's one thing to make it make sense is if I use my 0 product property to find my x-intercepts, I'm going to have to use the inverse. That's why that's getting the inverse, right? So if I use my 0 product property, set each factor equal to 0, I've got to use the inverse. The other thing to note is this. So, remember J. Mike said 3 earlier, right? And this makes a lot of sense. So, hold on to this. I'm going to give you a chance to take notes in a second, but I want you to see why it could not be 3. If I let x be 3, what's 3 plus 3?
6.
And then 3 minus 1? Is that going to give me the 0 that I need?
No, I don't think so.
No, I don't think so either. So this is not something I talked about in the past, but this is something I'm realizing it might be important to discuss. But notice if I use a negative 3 here, what's negative 3 plus 3?
0.
See how it has to be the opposite of that plus 3?
Yeah.
And then this would be a negative 4. Now I have a product of 0. So I need the opposite each time. When it's x minus r1, x minus r2, I need the opposite of what is right here. Does that make sense? Okay, so I need you to update your notes on which form? Factored form. I need you to update your notes on factored form, understanding that concavity, understanding those roots, and how to find them. Maybe show an example. Don't just write this down. Make sure you're understanding where it comes from. Ask questions if you need to, and I'll be walking around to help you with that. Once you are done with your notes, move on to the next slide and do some practice with it.
Well, what you did there?
Say again, Dakari?
So we're gonna do stuff like that?
No, never, ever.
Say again. Notes on your factored form, and then you're going to have some practice with this. Where's your factored form then?
I'll let that on.
So factored form, you need to write explanations of what A, R1, and R2 are doing, right? Examples, explanation why. You write, what A, R1 on the board. I want us to note here that a lot of us ended up improving as time went on, but concave up or down, are we all good there?
Yes.
Okay, what is determining the concavity every time? A. Whatever A is, guys, we got 8 minutes left. I don't know why a single person's packing.
Pack it up.
A determines our concavity. Now, at this point, I need to remind you, as soon as I see this equation, I need to recognize that as what form? Factored form.
Yeah.
What do I recommend you do, Taj?
Look for the X in this up.
What?
Look for the X in this up.
Yeah, it's not what I recommend right now, though. No, before that. I eventually want the x-intercepts because it's factored form. But what should you write first?
Concavity. Oh wait, now you need to write the equation.
Thank you.
Man, you don't need to technically.
Nah, but too many of us screw it up, so yeah. Listen, my first block, Advanced Algebra 2 class, about half of them crushed it. About half of them bombed it. And when I asked them, did you, one, do your check your understanding? The ones who struggled did not. And two, they did not write out the equation. Guys, if you write this equation every time you're dealing with factored form, what's that going to help you do with the equation? Remember it, right? So take the time to write it out above the equation every time. And then it's not complicated. Literally, it's lined up. Do I need to? No, but very clearly, what's my A? 2, so it's concave up, right?
Yeah.
Like instantly, if I write out that equation, I can clearly see A. What's R1? You think it's negative 3?
She just said it's
I'm pretty sure.
I was saying,
I'm pretty sure it's
Because you
possible.
do the opposite.
so remember, and I need us to pay attention to this. Because it's x minus and x minus, I'm going to need the opposite. Now I want you to remember, the whole point is that these are y-intercepts, right? Or x-intercepts. So what's the y value? 0. So if I were to substitute a negative 3 into here,
Yeah,
would that give me the 0 that I need?
I'm pretty sure it would.
Yes, it
Yes.
Oh, yes.
Sure?
No, that'd be
Does that give me the 0 that I need?
No, sir.
No. So I need you to remember, the whole point is that we're trying to make a 0. So I can't use negative 3, but if I did the opposite with a positive 3,
Yes.
what's 3 minus 3?
0.
3 minus 3 is 0. What's 3 plus
I
7?
thought 3 might have won my fault.
3 plus 7,
That's 10.
that's 10. Does that give me a product of 0?
Yes.
Notice that is the 0 product property. I'm literally multiplying by a 0.
Yeah.
When do you do
So R1 is a positive 3. So what's R2?
R2 is, negative 7.
That's a plus 7, so why would it be?
You gotta switch it, boy.
So Kari, that was a minus and it was a positive,
Oh,
right?
that's what you're doing.
When it's a positive or a plus, it becomes a negative.
Yes.
Okay, we need the opposite. I cannot make that more clear. I cannot emphasize that enough. You need the opposite when you have that factored form. And once again, check it. What am I trying to create? A zero. So if I substitute negative 7 in, what's negative 7 minus 3?
Pretty sure it's negative 10.
Negative 10. What's negative 7 plus 7?
Pretty sure 0.
Did I create a product of 0?
Yes.
So remember, I need the opposite so that I get a factor and a product of 0. I hope that helps these things make sense, but you need to make some notes about this. One, your roots are always the what? Opposite. Your roots are the opposite of what we see in the expression because we need that product of 0. Please update your notes to your future forgetful self because we've still got 3 minutes and most of it's packed up, so we can't take any notes.
My